So, now dielectric polarization. What happens when the dielectric materials are placed in electric field? So, now see here, if just I am taking first example of the non-polar dielectrics. What happens in non-polar dielectrics? If you can see the picture of one molecule, it is something like that. This is plus and minus, center coincides. But when this molecule is placed in an external electric field, this happens something like that. This is the minus center comes here and plus center comes over here. So, now the centers of the negative and positive charges are separated by a small distance. So, now we can say this is behaving as an electric dipole. Now, see, let us discuss here with the external electric field here in detail. So, this side I am taking here the positive and this side is negative. Now, external electric field is E naught to this side. Now, if I place dielectric material over here, what happened? Initially all the molecules of this, all the atoms of this dielectrics are like this. Now, in the presence of electric field, they becomes like this, something is a negative positive, negative positive, negative positive, negative positive. So, elongation of the atoms takes place, negative comes to center of negative comes to the end of the positive side and the positive center of the positive charge goes to the end of the negative side. So, here an electric field is induced inside it, that can be written here EP. So, here polarization of the dielectric is taking place. Now, in this case, suppose whole dielectric suppose behaves as a electric dipole. Plate of the area of the dipole, sorry, dielectric is A and the distance between or the width is D, then we can write here dipole moment per unit volume. So, we can write here electric dipole moment per unit volume is equal to, we can take QP, this is the induced charges over here, this is QP plus here. So, this side is minus QP into D, that is the width of the dielectric, and I am assuming here this whole dielectric behaving as dipole, and here this is area into D here, this D will get cancelled. So, you will be getting here QP upon A. QP is an induced charge that can be plus and minus, and so this can be written here sigma P. So, that is called the induced charge density, and this electric dipole moment per unit volume also is known as polarization, and we write here this is the symbol, this is polarization, and polarization means actually electric dipole moment per unit volume, and its magnitude is usually referred or taken as equal to the induced charge density. So, now see inside dielectric we have seen the outside electric field is E naught and inside dielectric these type of the dipole moment dipoles are developed. So, EP is to this side. So, net electric field inside dipole moment can be written E is equal to E naught minus EP. So, electric field actually inside dielectric reduces here. So, in this case the polarization density, or you can say simply the polarization, is directly proportional to net electric field inside the dipole, and that can be written P is equal to chi epsilon E. Here this chi, this is pronounced as here chi, and this is known as electric susceptibility. So, actually it is a proportionality constant and known as electric susceptibility, and here epsilon is multiplied here, that is taken as multiplication factor to make chi dimension less. So, this is here the polarization or the polarization density is equal to this. So, now let us discuss relation between here the chi and dielectric constant of the material. So, inside dielectric we know it, that is electric field E is equal to can be written E naught minus EP, and here this EP we can write E is equal to here E naught minus sigma P upon epsilon, So, we can write here E is equal to E naught minus, that is P upon epsilon, P is polarization density. So, we can write E is equal to E naught minus chi epsilon E divided by epsilon, this will get cancelled. So, now we will be getting E plus chi E is equal to E naught. So, we can write 1 plus chi is equal to E naught upon E, and that can be written here equal to k. So, 1 plus chi is equal to k, where k is known as dielectric constant. So, this is the relation between dielectric constant and electric susceptibility. Now, see here another case. In this case, suppose in place of the dielectric material, if you are taking any conductor in electric field, suppose I have taken here plus and here is negative. Now, I am placing here a conducting plate. What happens here? Negative charges are here induced and here the positive charges, because the charges are free to move, and this induction takes place until equilibrium is attained. So, E naught is here and EP is here. So, as E naught is equal to EP, the movement of the charges stops. So, we can write net electric field inside conductor is here E naught minus EP, that is equal to 0, because these two are equal. So, this is in case of the conducting plate. So, we have done here just now the dielectric constant, its relation here. So, dielectric constant for metallic body is taken as infinite, and electric field inside the dielectric material, or if any material is placed, then we can write here E is equal to K is equal to E naught upon E. E is the electric field inside the medium, and also we can write K is equal to F naught upon F here, that is relation to the electrostatic force. And also we have done previously epsilon R is equal to epsilon upon epsilon naught, that is a relative permittivity of the medium.